Okay, Bismillahirrahmanirrahim. Assalamualaikum guys. So my name is Nuria Ajana binti Rizman. My matrix number is 1203161. So today I would like to present about chapter 3, which is alcohols from carbonyl compounds. Okay, let's see what's on the next slide. Okay, on this slide, to be more specific, I will explain about alcohols from Grignard reagent. So let's go. Yes, let's take a look on our contents for today. As you can see on the slide, we will discuss about how to plan a synthesis, the restrictions, the use of lithium reagents, and the last is the use of sodium iodide. As you know, all this topic will explain more to Grignard reagent. Okay, first, we go through our first subtopic, which is to plan a synthesis using Grignard reaction. There are three methods, which is method 1, we use a ketone with 2 ethyl groups, 3 pentanone. Second, we use a ketone containing an ethyl and a phenyl group. And the last method is we use an ester of benzoic acid. Okay, now we go further for our first method. This time I will use 3-phenyl 3-pentanol to synthesize. So as we know that synthesis is about reverse techniques, which means we need a retrosynthetic analysis step to create a synthesis. So here we can see that there are a dotted line spot in the compound. The dotted line means that they are about to separate. So it will become like the first reaction. So for the second step, we just need to list down back the product on the first step. So the reaction will be like this. When phenyl magnesium bromide react with 3-pentanone, will give a product of this compound back, which is 3-phenyl 3-pentanol. Now let's proceed to the next method. The same as before, but the dotted line is in different place. For our first method just now, the dotted line is directly cut from the cyclohexane. For this time, the dotted line is cut on the first ethyl. Like before, the reverse techniques is used, so it will become like this, which is the second step. When the ethyl magnesium bromide react with the ethyl phenyl ketone, it will produce 3-phenyl 3-pentanol. For our last method will become like this on the first step or the retrosynthetic analysis. As we can see here, the dotted line cut on the both ethyl part. So this will give us the product, which are ethyl magnesium bromide and methyl So just like before, for our second step or our synthesis step, the reaction will be like this. When ethyl magnesium bromide react with methyl it will produce 3-phenyl 3-pentanol. So I hope you guys will understand what I'm trying to tell you. But if you guys cannot understand it, just take a look on our textbook, page 555 until page 556, or you can look further on YouTube. Okay, now we will proceed to our second subtopic, which is the restrictions on the use of Grignard reagent. Let's proceed to the restriction on the use of Grignard reagent. There are 5 points. First, we know that Grignard reagents is very powerful base, so it is not possible to prepare a Grignard reagent from a compound that contains any hydrogen more acidic than the hydrogen atoms of an alkene or alkene. We can say that if you want to prepare a Grignard reagent that contain any of these on this box below group, it will bring you nothing. Means that the reaction is failed to take place. So this will lead you to the next restriction, where we cannot prepare a Grignard reagent from any organic halide. Look at this below. These are the group from organic halide. Since we know that the Grignard reagent also a powerful nucleophile, so when we prepare this, it will react with this group. When we prepare a Grignard reagent, we effectively limit it to alkyl halides or to analogous organic halides containing carbon-carbon double bonds, internal triple bonds, ethane linkage, and NR2 groups. So here, we just need to take a good care while preparing a Grignard reagent, since it is so sensitive towards acidic compound. Other than that, we can make acetylenic Grignard reagents by allowing terminal alkynes to react with alkyl Grignard reagents. So here I give you an example from the Wiley textbook. So you guys just turn into page 558. And the last restriction is when we plan a Grignard reaction, we also must take care that any aldehyde, ketone, epoxide, or ester that we use as a substrate does not also contain acidic group. If that happens, the Grignard reagent will react as a base with the acidic hydrogen rather than reacting at the carbonyl or epoxide carbon as a nucleophile. Go to the next slide. It's pre-final, guys, so keep watching. Now we will proceed to the use of lithium reagent. Why so sudden? Just now we talked about Grignard reagent, right? But how and why this lithium reagent interrupt? Okay, let's see. In short term, we can use lithium reagent to prepare alcohol as an exchange because we noted here the lithium reagent is more reactive compared to the Grignard reagent. When we look at this example, the way for the preparation same as when we use the Grignard reagent. So don't worry, be happy, okay? Now it comes to final. What is the topic of the final? Okay, the topic is about the use of sodium alkanides. So let's go. Last content for our topic today is about the use of sodium alkanides. As simple as I can say, this sodium alkanide also can be react with aldehydes and ketone to prepare alcohols. Just look at the example. This explains that sodium alkanide reaction also same as lithium reagent, which means that we can use this to replace Grignard reagent. So that's all from me. Thank you.